I grew up in Virginia on a farm. That's where my grandfather had a dental practice in his home. Then my dad became an orthodontist. My mom was an associate at a dentist's office. Our family vacation was going to orthodontic conferences, playing with the sons and daughters of orthodontists. I thought everyone's parent was an orthodontist. I always wanted to be a little bit different. So I took an unusual path in dental school. I did a DMD and a PhD together. I've always loved wearing many hats. When I was assisting my dad, I would watch him bend a lot of wire and reposition a lot of brackets. I would always ask him, Dad, all you do is bend wire all day. And he would explain it to me that I'm trying to accommodate for a one-size-fits-all bracket and a very unique set of teeth and jaw relationships. That instilled in me from the beginning that there's a value to customization in orthodontic treatment and that no two patients are alike. Traditional braces are still one-size-fits-all, which can make traditional treatment plans inefficient, time-consuming, and painful, often moving teeth where they don't need to be. That's why LightForce is changing the face of orthodontics. Our digital platform empowers orthodontists with 3D tooth movement tools that offer unmatched customization and precision. Our first product is a line of 3D printed brackets that conform to the precise contours of every tooth to create direct and precise movement. The result? Happier patients, happier office staff, and the new gold standard for clinical efficiency in every case. There hadn't been a 3D printing technology that made it possible to make a clinically acceptable bracket until very recently. When Dr. Lou Schumann and I founded LightForce, we wanted to create a company that was by orthodontists for orthodontists. Long term, what we think LightForce will turn into is a platform for customization for all tooth moving tools. Full customization has always been the goal for the last 70 years. This is the first technology that enables that. Patients today are all about efficiency and speed of treatment, and they don't want to see the orthodontist 20 times if they can see the orthodontist 10 times. They also value the experience. The other thing is if we have to move their teeth less, there's less pain associated with that. I didn't know what I was going to do when I was growing up. I always had an idea that it would end up in the dental world somehow, but did I ever think I would be doing this, interacting with the world's best engineers on a daily basis? No, but very lucky to have the opportunity. And I still get to practice and have that patient interaction, which I couldn't do without. When people think about LightForce, I want them to think that this is the best company at listening to orthodontists and making their ideas come to life. We're not telling orthodontists how to use this system. We're asking orthodontists what's possible and then welcoming them into the journey with us. All right, so start with a little bit of positivity this morning. The last time we had a big economic recession was 2008, 2009. And one thing we learned from that event was that patients and parents really value what we do. This is an article from the New York Times, and that was made very clear that, while we did see a drop in some adults getting treatment, what was very clear is that parents really valued straight teeth for their kids. And so when we come back, obviously we have to battle not just the economic issue, but there's also, biological and the psychological aspects of coming back to practice. But one thing that we should always remember is that orthodontics is not a quote unquote vitamin. It's an antibiotic. It's something that people and parents especially deem essential for their kids. So a little good news there. Our goal here is to meet patients where they are. People have changed quite a bit over the last few decades, and we've learned to rely on companies and startups that have changed ways of life. So people aren't going to the movie theaters as often anymore. They're watching Netflix. Obviously, we're all on Zoom with varying degrees of success. Peloton, that's something I wish I'd got on board with a few months ago. Our patients are the same consumers of these technologies. And one thing that's become very clear is that they value convenience. So we should do our best as orthodontists to help them adjust to the orthodontic world when they come back. Meet them where they are. So where we are today is that we see patients a lot of times. The average is about 17 times for fixed appliances. Obviously, it changes a little bit with clear aligners, and that's part of the value of clear aligners. The other thing with fixed appliances, appointments can take a little bit too long and they can be unpredictable. So, from the initial bonding appointment being hour 15, hour and a half, to adjustments where we repo brackets, maybe we bend wires, we're not exactly sure what a lot of patients are going to come back with when they see us. So starting with the end in mind can be very helpful there too. And the reason is because we're using analog treatment planning tools. We're using a one-size-fits-all bracket, and we're being reactive versus being proactive with our treatment plan. So just talk a little bit about the technology we use today for brackets. Brackets today are made via injection molding, primarily. There were some that were milled, but they ended up being a little bit too expensive to manufacture. A little bit more accurate though. So with injection molding, we use molds that are generic and fixed. It takes many years to make these molds. They're very expensive to make as well. And but once we make them, we can crank them out. We can make many widgets or brackets very efficiently. The slot walls end up being divergent though. It's part of the reason is they need a path of draw to take them out of the mold so they don't jam in the mold. They can be ejected efficiently. Call that a draft angle. And the molds wear down with use. So sometimes they get replaced. Maybe they replace an upper left 3, but not the upper right 3. And there's a lot of great literature in angle about this as well. Dr. Brown from Detroit Mercy published a great paper. So within a series, we have many different slot sizes. And then part complexity is limited. So when we talk about making a mechanically locking base, this is usually done by a post-processing step where they'll laser etch a base in the ceramic brackets, or they'll tack weld a mesh on the back of our metal brackets. They're not made from one solid piece at the beginning. So mass customization is ideal for orthodontics. And this is not a bold claim. This is actually something that everyone in the 3D printing industry already understands. Everyone thought that at the beginning, orthopedics was going to be the savior of the 3D printing industry. But what we realized is that in reality, you can be 2, 3, 4 millimeters off on a hip, femur implant, something like that, and it's going to fit pretty well. The matrix, skeletal matrix is going to adapt and make that thing fit. Whereas in orthodontics and in dentistry, if you're half a millimeter off, a millimeter off on an occlusion, like a crown, patient's going to feel that when they bite down. So there's just a higher value to customization in orthodontics than any other medical specialty, we believe. And the biggest success story of a scaled 3D printing application is Invisalign. So give credit where it's due. And that's awesome for aligners, but that's used for a smaller percentage of our cases. So mass customization is ideal because faces and jaws are unique. We all know this as orthodontists. We preach this to our patients every day. Obviously, teeth are as unique or more unique than fingerprints. That's why they're used in dental forensics. And in tooth anatomy affects our functional prescription. And then also, orthodontics is a very data-intensive specialty. So we're looking at not just contacts on a few teeth as orthodontists, we're looking at the contacts on all of the teeth. And then we're looking at the Bolton discrepancy, the tooth sizes. Do we need to IPR, the perio status, soft tissue, skeleton, lots of things to consider that our diagnosis can all be aided via 3D data. And so that's why we believe software is going to help orthodontists do a better job. So mass customization has always been the goal, and big tip of the hat to guys like Craig Undrako over here. Would have loved to have met that guy, brilliant orthodontist. But we've been after customization for a long time. That's why Andrews first invented the prescription edgewise appliance. That was an attempt at more customization, reducing wire bends. So our profession has slowly evolved to make life more efficient for us, to reduce the manual steps. And today we still make bends, sub-millimeter bends with pliers. That's obviously not ideal. And when you describe this to non-orthodontists, they think that's a little bit archaic. But we know we can still do a good job doing that because that's how we're trained. But this has been the goal, and we see LightForce as a continuation of that goal. One important thing to mention is that mass customization for braces is only possible with 3D printing. And this is the only way you can get full customization. So there are other technologies like milling, subtractive manufacturing that are used for crowns. Not possible to scale that with brackets because you have undercuts and other things the burr will wear down. Not possible to make this at scale with subtractive manufacturing. And then injection molding, you just can't do it at scale. It takes months to make a mold. It would make zero sense. So again, 3D printing is the only way to do this. This is why we put all of our efforts into this technology. And now we get to LightForce. So LightForce is a platform, a technology platform for mass customization in the orthodontic space. Our first product is fully custom brackets, but as many of our users know, that's not where this is going. There's a bigger vision here. So again, this is our first product, and part of it is software that exists on the cloud, part of it's hardware. And then we've been able to make enough of these for everybody. But the whole idea here is that versus being reactionary, we start with the end in mind, and we start with the end in mind and anticipate where the teeth are going to move such that the teeth end up at an optimal final position. And we use 3D data to help us get there. And we believe this is the perfect application for 3D printing. So I always use this analogy, but you could 3D print a coffee cup. And actually, if you stick around, I think you can get one of these. But there's a high value to customization with brackets. So, I mean, there's not really a whole lot of customization in a coffee cup. That's great. But who cares? Custom handle, whatever. High part complexity. So this is simple. There's no complexity here. You could injection mold this if you want to. And, this is only $3 or so, or less than that, to make. So we need to have a justification to charge more than $3 for a bracket. But this ticks off all of the reasons you would want to 3D print something. So what is a bracket? A bracket is really nothing more than a connection from a tooth to a wire. And our goal with these custom brackets is to take all the air in that system away so that the connection from the tooth to the wire is exactly where it needs to be to control the vectors of forces. We've argued about prescriptions, we've argued about forms of ligation, and we've lost the forest for the trees. What really matters is what vectors of forces are we applying on the teeth and how accurately can we apply those vectors of forces. So today, what we do looks a lot like this. We are putting a stock bracket on a tooth, and by line of sight, and with loops and tongue and all that stuff in the way. And the bracket can rock. Even if we place it ideally, there's going to be cement space there, and which is going to reduce the bond strength. And then to finish, we'll make bends in the wire, which is okay, and we can do a good job there. But we thought that a more efficient way would be to make a fully custom base, so the anatomy is not a variable for bond strength, and end up with a straight wire. And this is what we mean. So a fully custom bracket also has a custom base. Customizing the slot is just half the equation, and our take really only offers about 25% the value. It's really a 1 + 1 = 3 or 4 scenario when you have full customization. So you have a consistent cement space. So regardless of the anatomy of this tooth, whatever the mamelons look like, you're going to get the exact same cement space and the exact same consistent bond. That results in precise and predictable bond strength and no rocking. So there's a lot of value in having a custom base. We've been able to do that on the lingual before, but it's never been done on the labial. And we have seen already, and I can say this anecdotally with conviction, still waiting on that clinical trial, we've seen a lot fewer bends and repositions, if any. So we'll get to some of that later. Okay, so this is a pretty big paradigm shift in how we think of fixed appliances here. Brackets are created based on the tooth position, not based on a predisposed idea of a prescription. So if we watch this little GIF here, you can see we move the tooth down and the bracket will change. The torque doesn't change at all, and it shouldn't, because we don't care about bracket torque anymore. We care about tooth torque, and the tooth torque isn't changing. You see that bracket base change tremendously. So again, new way of thinking. We should be caring about the teeth, not the appliances getting us there. With clear aligners, we're not designing clear aligners. We're controlling vectors of force, to steal a line from Dr. Moshiri. So the next thing that 3D printing allows is for arch plane freedom. So we can put this arch plane anywhere we want to. And we may want to be avoiding occlusal contacts. Maybe you want to put the arch plane a little bit off the gingivus to help with hygiene. But what's important here is that we maintain torque the whole time, the ideal torque. There's no adjusting needed based on the bracket position. And this makes it much easier than traditional indirect bonding setups because we don't need to think as hard. We just need to know where the teeth are going to be, and then we know the algorithms are going to adjust the brackets to meet that tooth position. This is one thing we talk about with the residents quite a bit, is that the most important part of a stock bracket prescription is the position on the tooth. Because as we know, the tooth, the labial morphology is quite variable, and if you put a bracket higher on a tooth versus more occlusal or incisal, you're going to change the prescription tremendously. So when you think about it like that, it's kind of silly that we've been arguing for decades about whose prescription is the best, and it's might vary by 3 or 4 degrees. It really depends on where we put the brackets and what that patient's tooth anatomy is. So this was another interesting thing that we kind of stumbled across. I remember it was about a couple of years ago, and we had a case that came in, one of our beta cases, and like many cases we see today, there's crowding, there's rotations, and that's been a pain point for indirect bonding for many years, where if we have one tooth that's too crowded or too rotated, we can't get the bracket onto the middle of the tooth on the facial axis point. And then I think we had like maybe 3 engineers around the table. We all kind of figured this out at once. We're 3D printing these things. We can put brackets wherever we want to now. So this is what we did. And you can see here, you can put these brackets anywhere you want to on the labial window of that tooth, and you're not going to have a rotational penalty. So this makes just the whole indirect bonding process much more seamless. And in your practice, the important thing is that makes this technology scalable. Far fewer headaches to deal with. So then, of course, hooks, where you want them, when you want them. Maybe we don't want hooks on the lower 3s in our class 2 cases, or any other clinical scenario you want. But the important thing here is that putting hooks or not having hooks doesn't cost you any inventory. These are all on demand, which obviously helps with cash flow. So the next part of this is that we're doing everything on the cloud in a software. As you can see here, this is a GIF I created earlier today. This is all happening in a browser tab, and we start with the end in mind. Nothing to ever download. And then here you can see, due to a Bolton issue, we had a contact there. So we're just going to slide this tooth over a little bit so that we don't have that occlusal contact. But everything is done on the cloud, on a browser tab, nothing to ever download. And this is going to have big implications in terms of multidisciplinary care and sharing your cases with your periodontists, oral surgeons, prosthodontists, et cetera. And so I really like this slide because it captures what this new mindset is. So if you look at this picture and this picture, you're going to get the same exact result. Even though the wire plane is completely tipped in the wrong, a weird direction there, and the opposite weird direction there. What's important is that the software algorithms will adjust the bases so that you don't need to alter torque or vertical position. You're still going to get a straight wire setup. Now that obviously looks kind of wonky, and looking at it, no one's going to say you did a great job positioning, but based on 3D data and the algorithms, you're going to get the same result. Same thing here to here. So again, this is all about giving more control to the orthodontist and being able to put brackets wherever you need to make that case more efficient. Okay, so we talked a lot about the base. Now what's also equally important is the slot. So are we going to express our prescriptions? Traditionally, again, as I mentioned, we injection molar brackets, and this is literature from the Angle orthodontist coming out of Harvard residency, and there are many other studies that show this as well, but typically injection molar brackets are oversized and divergent. And that's what we see here. So as you can imagine, the implication for that is that we're going to get a lot of slot play. And we believe this is the mechanism for previous findings, such as that of Bertie Melson. She reported back in 2015 the slot play between a 1725 wire and an 018 slot and a 1925 and an 022. And as you can see, the slot play is quite a bit higher than the theoretical 4.2 degrees you should have. And it varies tremendously. And we believe that's because of the mechanism for that is the process of injection molding. So you can see we have 6.4, 13.4, and then over here we have wildly high slot plays up to 36 degrees. And so you're trained in residency that if you want to engage torque, you step up to a 1925. The reality is that the 1925 is acting like a round wire, pretty much. So we're not even though we're arguing about the prescriptions, we're not expressing them. So with 3D printing, we all know that we get those little striations in the plastic for clear liners. And that's because we manufacture things in layers. And so if you're 3D printing something that's round, you may get a little bit of staircasing because everything is done in layers. However, if the sensitive part of your device is a rectangle, you can make a perfect rectangle with 3D printing. And that's what we see here. So being very data-driven, we quantified this. And we also realized that even taking customization out of the way, 3D printing is just the best way to make brackets just from a slot point of view, slot accuracy point. So we get parallel slot, it's accurate, and it's precise. And the reason for that is that STL files, unlike molds, they don't ever wear down. So you're gonna get the same thing on every tooth. And then from a density point of view, we can make these more dense than injection molded brackets. That helps reduce things like staining, fractures, and we have a third less friction than injection molded ceramic because the slot is on a fully formed layer. And that's on file with the FDA. So again, being very data driven, we like to quantify everything. This is unpublished data internally, but you can see the slot play in our 018 is a little under 4. It's right around there for a 1925 in our 020 slot, which is what a lot of the 022 guys have gone down to. And then if you want to stay in 022, same thing, 1925 is about half of what you saw with the other injection molded brackets, because in this case, we believe that 018 and 022, they've kind of become brands more than slot measurements. And we're trying to use technology to raise the bar for the industry in terms of accuracy of the slot. It's not something that every orthodontist analyzes to death, but we know that it's an area that needs to improve. And so that's one area we hope to improve on. Okay. All right, so we're definitely enabling new biomechanics here, and we'll talk about that. So knowing the future has its advantages. So if you can start with the end in mind, this allows you to avoid repositioning. It allows you to avoid some wire bends, avoiding occlusal interferences with brackets. We'll show you some cases of that as well, and avoiding round tripping. So again, if you have that almanac for each case to know where each case is going to finish, and you use brackets that will get you there, you can be more efficient by trusting your eye ties. Let's listen to Biff here. So this is just one example of avoiding collisions and debonds. And focus in on this tooth over here, this lower right 5. So that's placed a little bit too far distally. I think most of us would agree. No one's going to get a good grade on that bracket position. And that's the initial view. This is the final view. So again, we start with the end in mind. That wire straightens out, and you're going to end up there. However, when you look at the upper arch, you can see why the software suggested we put the bracket there. Due to a Bolton issue, if that tooth doesn't change occlusion, and that tooth derotates, that's really the only place we can put that bracket and avoid an occlusal interference. So again, the software is helping us avoid an issue that will arrive later in treatment. And this is just another fun case. I took this shot, this is my last case before quarantine. But if you look at that bracket and zoom in, you can see, most people would say, Alfred, you botched that bracket position. And they're not wrong, but the point of a custom base is that you trust the software. And so, we're happy with that alignment, despite that bracket being, pretty far distal. And again, this is done if you have things like crowding that won't allow you to put brackets on the middle of the tooth. All right, so we'll get to a few cases here. So first one is blocked out tooth. So we had this tooth that was a little bit blocked out there. Otherwise, pretty straightforward case, little upper and lower crowding, no vertical challenges here. And we started the bonding, and we'll zoom on this in a sec. Worked through the wires, so started with 014 upper and lower, stepped up to 1622 on the upper, then same thing on the lower, and we ended up here. So we did, I think there's one appointment here we didn't see, but 5 appointments and 7 months. So normally I wouldn't have the confidence to tell that patient she's been done in 7 months and only see me 5 times. But, you know, we ended up finishing in a 1725 NiTi here. No wire bends, no bracket repos, no brackets coming off. And we were able to avoid a secondary bonding on this tooth. And I'll zoom in here in just a sec. So this is what that tooth looks like on the software at the initial view. This is what it looks like day of bonding. You can see we put an open coil in and we didn't engage that day of bonding. But normally what we do is we put a bracket there, bring it out and repo it on FA point, drop a wire. That's 2, maybe 3 appointments. In this case, we just bond a bracket there and leave it there. And so the idea here is that we start with the end in mind, and that's when the wire straightens out where we want to end up. And this is where we ended up. So again, no rotational penalty. And again, this is only possible with a fully custom base where you can put that offset there. And that's what the bracket looked like. And this is the summary of that case. So we're, again, 1725 NiTi here. Didn't even have to get into a steel wire, which is perfectly acceptable, by the way. If there's no vertical change needed, or you don't need that extra heft, NiTis are a great wire to finish in. So this next case really highlights the tip and the torque being expressed, because that's not something we're used to in orthodontics. We're not used to seeing the tip and torque really be expressed. Maybe the tip, but not as much the torque. So this case, we started with quite a bit of lower crowding, a little bit of upper crowding as well. A lot of recession, and the patient was a smoker, so didn't feel comfortable proclining and IPRing all of those lower teeth. And then we also had quite a bit of overjet here. So the treatment plan was to extract this lower tooth, the one that had recession, and then procline the remaining teeth, retrocline the uppers with a little bit of IPR, and then open the bite by putting a reverse curve into the bracket position, not the wire. So we did that by finishing with heavy contacts on the premolars. And in the extraction site, we put, for the adjacent teeth, we put 5 degrees of mesial root tip to help keep those roots parallel at the finish. So this is where we started with day of bonding. This is the tooth that we extracted. This is before we had our turbo trays. I'll show you that. Just working through the wires here, 3 months, 6 months, and then this is where we ended up at the end. And again, so we went 014, 1622 NiTi, 1622 steel. Probably didn't need that wire, and again ended in a 1725 NiTi. Okay. So, and as you can see, we're happy with the end results. And we'll show you the pan here. So this is the initial pan. This is a PA of the lower incisors right after the extraction, about 3 months after the extraction. And you can see the crowns tipping into that extraction space. Now remember, we put 5 degrees of root tip into the extraction space. So this is 014. Let's see what happens when we get to a 1725 NiTi. You can see here, if we zoom in or highlight it, you can see that we might have even overdone it a little bit. So 5 degrees of root tip is quite a bit with brackets and wires. It's, you know, a different story when you're working with clear aligners. But 3 months into retention, you can see we're actually pretty happy with where those roots ended up. So, you know, forgetting LightForce for a second, it's kind of interesting to see what relapse happens even in an Essex retainer. But the key here is that we overcompensate some of these movements, and what you put in, the tip that you put in, actually does happen. Same thing with the torque. So again, this is the initial Ceph, patient's brachycephalic. That's where we're okay with proclining the lowers a little bit, and had quite a bit of overjet in CR. So 10 months later, just working through the wires, letting the NiTis do their job and express torque gradually versus bending a wire and jamming it in. you can see we were actually able to control the vertical and the torque simultaneously. So we controlled the vertical to help improve the overbite, and then we controlled the torque to help control the overjet and the anterior coupling, even with one less lower incisor. So normally you have overjet, you lose lower incisor, you make the overjet worse. In this case, you can see because we were able to control torque, even with one less lower incisor, we were able to improve the anterior coupling. That's a tough thing to do with stock brackets, especially in 10 months. So this is a summary of that case. Okay. So this is another one of my favorite features, and Dr. Jacquie is going to talk about this a little bit as well. But traditionally what we do with cases that, what we did with cases where we couldn't drop the arch wire plane low enough is we would just put a blob of composite back in the posterior because it's easy to do. Ideally, we would make anterior turbos to help open the bite, but those take sculpting, and you have to take out the occlusal contact paper and use a burr. So we realized, hey, we know where these lower brackets are going to be. If we have the Ceph, we can use the Ceph to identify the hinge axis of the jaw and open the bite just the right amount. So we should be able to make what we call a turbo tray. And that's what this is. So we open the bite just the right amount and send your staff a indirect bonding tray for turbos. You put band lock or triad, whatever you want in there, and it's going to be at the exact right position. It's going to be deep enough so you don't trap the bite. It's going to be at the right vertical position. And the occlusal table will be parallel to the lower arch plane. So no adjusting at all. And at default, what it does is it opens the bite exactly 500 microns from the first contact with a bracket. And the software detects that for you. And a lot of people ask us, well, why 500 microns? This is kind of a form meets function type of thing. So we know that the periodontal ligament in adolescence at its biggest is about 300 microns. And so we design it such that even when a patient really bangs down hard, day of bonding, they're still not going to hit a lower bracket. But at the same time, they're not too open so that they're not, they're as comfortable as they can be. And we offer these on the lingual of the upper ones and on the lingual of the upper threes as well. So, okay. And this is what we get with all this. We get what we call a fully delegated braces start. So I would say about 75% of our users are doing this already. Many more are adjusting to this. And this is a slide from Dr. Waldman, who spoke at the AO yesterday. But your staff should be able to do all of this for you very predictably. Everything is built with that kind of Apple approach to product development where it should just work. And I'll get to that and how we do that in a sec. Okay. All right. So the clinical workflow here is very similar to what we do today with clear aligners. So we start with a scan. Patient comes in, you take a scan and take a down payment, and then you have them back in 4 to 5 weeks. So it's the exact same scheduling as you would for clear aligner patients. That really enables you to unify your practice workflow around the same digital workflow. Once you submit the scan, you'll get a setup from us within 48 hours. We take a lot of pride in the quality of these setups and on the timing of it. That's a big part of the user experience is quality workflow, quality setups, and do you get things in time for bonding. Then we manufacture and ship them in 7 to 10 days. And once you get them, you should be able to bond in 30 minutes. Your staff should be able to bond. And I'll go through that process in a sec here. So day of bonding, first thing you do with your staff is have that in the initial huddle meeting. Look at all the LightForce bondings you're going to have, and you can look at the arch wire deflection before the patient even gets there. This allows you to lay out that starting wire, whether it's an 012, 014, maybe you can start with a 1616 NiTi or something like that, or higher. Point is, it's up to you, and you can find that out before the patient gets there. Then you can have the staff pre-paste all the brackets and then use the packaging as a light box. So you can do this up to 3-4 hours before the patient even gets there. This is one of my cases, and I use transbond color change, but we've used every cement for this. Again, it's 100% mechanical locking base and a polycrystalline bracket. So people have used Flotane very successfully. We've had very great success with LCR as well. So lots of different options there. Then when the patient gets there, you want to etch and prime all the teeth and isolate the way you normally would. And then you put the trays on and you light cure. And I'll show you a quick little video of this. So one thing that's important when you bond these trays, these are smart trays. There are at least 7 algorithms that are very unique to LightForce. These brackets are manufactured to be indirect bonded. The first brackets that are manufactured with that intention in mind. And so one of the cool parts of the indirect bonding tray is that just by virtue of seating it fully vertically, the brackets already are placed in the correct amount of labial force on each bracket. So you don't need to put your thumb on any bracket. In fact, that'll cause you more harm than anything. So I'll show you this video here. So as you can see, this is us bonding one of the last trays, the upper anterior. But notice I'm just placing vertical force on these trays. No labial force on the brackets. Again, that's all intended. Another one of the algorithms involved here is identifying the path of draw, so such that these trays can come off very easily so they don't tear. Indirect bonding is a real linchpin to any fully custom system. And so this is why we spent many, many years really refining and fine-tuning all the details of this tray. And you'll see it's quite different than what you've used before. So, okay, and then this is the debonding. So debonding is very simple. This is actually my dad debonding one of his first patients. You use a Weingart and you just place mesial and distal pressure on the side of either side of the bracket. And so you don't need any new ply or anything like this. And there's an intentional defect in the back of the bracket that is, again, calculated based on the labial convexity of each tooth. That is, so even the debonding mechanism is unique to each tooth. There are many levels to intelligence to each bracket here, but whole point is that you should be able to debond without ceramic brackets exploding, and it should take you about a minute, just like it per arch, just like it took my dad there. So, okay, so this is how we do cases today with stock brackets. So typically, we take about 90 minutes for the bonding appointment. And then we'll work through a sequence of wires, let the wires straighten out, and then we'll do a pan repo and adjust and do some more checks. And these checks for bending wires or repoing brackets and maybe bending torque into the wire, a lot of different things. But what if we could get to a position where by the time we get to that pan repo, we're already debonding? So that's the goal of LightForce is we're not, obviously we've seen a lot of cases finish faster, but the real goal here is to avoid appointments and be more efficient clinically, both for your sake, so you can make more profit per appointment, but also for your patient's sake, so they don't have to see you as much and miss as much school time. So just to summarize here, the goal here for an orthodontist, the value to an orthodontist is to sell more cases, really differentiate your practice, meet patients where they are, especially in this new world where they want to be efficient. And they ideally want to avoid office visits if they can. We want your staff to be efficient so that you can increase your capacity, especially given maybe the constraints we'll have with new PPEs, new protocols just to see patients. And then we want to increase your profit per visit and profit per case as well. And so there's a very strong business case here. I'll let Dr. Jacquie talk about in a little bit. So thank you all. Great speaking here. Again, wish I could see you all in person. If you have any questions, please email me at alfredg@lightforceortho.com. If you want, we have these pretty cool Yeti mugs with LightForce on them. So that's one of my favorite parts of AAO is that you get some freebies. So we didn't want you guys to go without some freebies. So just contact me in the chat and we'll be sure to get one of these out to you. And with that, I'll introduce Dr. Jacquie. So very excited to have Dr. Jacquie Fulop-Goodling on here, otherwise known as Dr. Jacquie Smiles. Very influential orthodontist who is very well known in the epicenter of Midtown Manhattan. She's very academically credentialed as well. She's the first female director of BU, trained under Gianelli there. And she's lectured and taught over 17,000 orthodontists, so an incredible educator. We're really excited to be working with her. And very involved in the business world as well. She's launched orthodontic hygiene campaign on the Tyra Banks Show. She has several patents, very familiar with that world, has a whitening product, and she even launched Invisalign Teen. So she was one of the early users of clear aligners back when people were first learning about mask customization. So for us, it's really cool to see her involved in the next wave of mask customization. And we credit her with a lot of things. She's an incredible thought partner. Also helped us drive, along with my co-founder, Dr. Lou Schumann, another GNLE grad, the whole bidimensional 022 and 018 combination. So mixing and matching there. But she's a LightForce early adopter as well, and I'll turn it over to her. Really excited to hear from you, Jacquie.
Thanks, Alfred. It's an honor sharing this virtual stage with you and being a part of this year's American Association for Orthodontics annual event with our friends and colleagues, especially being a part of our next generation of learning. What a difference a year makes. In the last 2 to 3 months during this COVID crisis, technology has advanced and catapulted us into 10 or more years of forward-thinking education, including orthodontic education. So much so that earlier, a buddy of mine called me from London and asked if I could answer some questions about LightForce after today's presentation. She asked me what medium. And had it have been January, medium, I probably would have said we'll go into a seance. But now I knew exactly what she was talking about. Zoom, Google Hangout, go to webinar, join me, log me in, Ring Central. I just WhatsApped her back and simply said, let's do it the old-fashioned way. Let's FaceTime. Year after year, I have enjoyed the AAO's annual event. It's a great platform, getting together with our colleagues, learning, exchanging ideas, brainstorming, and of course, having fun. These are some photos from last year's AAO in LA when I was introduced to LightForce. And here I am with co-founder and dear friend, orthodontist, and proud to say BU alum, Dr. Lou Schumann. So over the last couple of months, technology has really advanced, and my presentations that I used to give live are still live, just on a new platform. Here is my German Shepherd disguised and dressed like a Chihuahua, who found her new favorite pillow in my new headphones. If anyone's going to need a little therapy after this, it's definitely going to be her. And this is what she looks like when I try to take the headphones away. This is my new norm. I am honored to be on this virtual stage, and I am an early adopter of LightForce's custom fixed appliance system, which I always say is light years and force ahead on the orthodontic charts. I don't know if that's how you named it, never asked. So I'm going to jump right in. Why fixed appliances? Why custom 3D brackets? And why LightForce Orthodontics? Especially for someone that was certified in the first group with Invisalign and clear aligners, and has taught thousands of orthodontists and had an Invisalign-only practice. It's really simple. I needed an aesthetic alternative in the fixed appliance industry. And I also wanted to take patient compliance out of the equation. But with that being said, I know that my patients value efficiency. And most importantly, I wasn't willing to give up the technology. I wasn't going back in time. Like Dr. Waldman said yesterday, we're not going back to the future. Patients value efficiency in their busy lifestyles. I practice in Midtown Manhattan. And yes, the center of busyness. Now the epicenter. I'm not so sure about the busy part, but I know my patients do appreciate and value their time. And today, they really expect it. I was exposed early on from day one, academically and also in private practice. I enjoyed bringing new technology into my practice because it catapulted and escalated my office to the next level. I did things that I liked, and I did things that I was really good at. So my first taste of digital advanced technology was when I opened my office, because when I did, it was the inception of mass customization in orthodontics. Hold on, someone really wants to get a hold of me. I am so sorry. So 4 months later, I was certified in Invisalign. I opened my office, and then I was certified in Invisalign. I was getting my master's in education, and I became the director of the pre-doctoral orthodontic department at BU. And my bidimensional mentor, Dr. Anthony Gianelli, MD, DMD, PhD from Harvard MBU, was our chairman. We had 8 residents each year. And when I started teaching, I remember him coming into my office. We shared one, and then there was carousels of Kodak little x-rays. And he said, guess what? The Joint Commission of Accreditation is accrediting the pre-doc and post-doc departments together. You have 18 months to get it done. Make sure we pass. So I know several people on this call probably don't even know what a Kodak carousel slide looks like, but I had to order one because we didn't have one in the department. So Dr. Gianelli and Drs. Bednar, Blau, Dietz, Dreisen, Walker, and even Dr. Giuliano Mino, they taught and predicted and preached predictable, consistent tooth movements, reduced chair time, excellent aesthetic and functional results with anterior torque control. That's what Dr. Griffin just mentioned. So we're probably about 80 years past due. Up until now, orthodontists were customizing themselves around a system, no matter how much of a straight wire system it was. If you were a better wire bender, then you finished in a more timely manner. The closer you finished at the time that you told the patient, the better of an orthodontist you were. So orthodontists were being customized around a system because of the inherent shortcomings of the stock injection molded bracket. If brackets had too much cement on it, then it rotated, not ideally. If they were blocked out, you couldn't put a bracket on. We always had to put them along the long vertical axis of a tooth. Well, now you have a bracket that's 100% customized around you, your patient, and your system. When you wrap your head around that, it's kind of uplifting, it's revolutionary, and it's definitely profound. I call it emerging orthodontics on steroids, actually. Emerging orthodontics on steroids. How relevant is this today? Well, it's more relevant than ever. LightForce's advanced technology allows for fewer visits, longer intervals of time between appointments, and in today's new norm, shorter appointments further apart equals less contact, making it a 3D bracket system ahead of its time and ideal for today's orthodontic world. It's a win-win for both the patient and the team. The digital workflow, well, it's very similar. If you have already incorporated clear aligners into your practice, it's very similar. You always have the end in mind. After you scan your patient, this system allows you to treatment plan them, design their smile, and LightForce brackets are going to be 100% customized for your orthodontic digital treatment plan. It's really bringing virtual world ideas to real world outcomes. One of my favorite features is being able to show a patient what they're going to look like at the end before they even start. I love that with clear aligners. It was one of my favorite features. They'd sit down and say, guess what? You don't have to think or figure out what I'm thinking. I'm going to show you. So yes, build it and they will come. It's a unique and individualized prescription. I tell my patients it's like a fingerprint. Your mother can't wear it. Your brother can't wear it. It's truly customized just for you. It's a true custom smile. So now I'd like to introduce you to Joseph. And Joseph is my 19-year-old patient. He is first year in college, double major, computer science and marketing. And this is his smile. His younger brother has palate expander. His older brother had clear aligners. And he said, you know what, Dr. Jacquie? I really snack a lot. So I didn't really want something that was in and out. I am in my first year. I'd like something aesthetic. So we went, and here's his Panorex. He has some impacted canines and his Ceph. So we chose 3D custom printed brackets. Think about it. His older brother had custom removable appliances. He's getting custom fixed appliances. And in this, they call it indirect bonding. But although systematically it's similar, I don't think it's similar as far as reputation. Early on, when we did do fixed appliances, my first 5 years, when I had to convince patients that clear aligners were the holy grail, what we did was we did a lot of indirect bonding. And I would bond them, I would make a circle around the chair, and I'd pray that all the brackets stayed on. And if they did, it was a good day. With this system, I call it the LightForce transfer tray because they're pre-designed trays, 3D printed, with the precise bracket transfer to the patient. And you don't need much pressure on the facial surface. You don't need any pressure at all. Just the right amount of cement, place it on, cure it, and you're good to go. Here's Joseph, and this is 7 weeks. This is him with an anterior crest bite, and this is 7 weeks later. Probably just about the amount of time that we've been in quarantine. So why LightForce? And how and did I introduce it to my practice? Well, you see, I practice in Manhattan in an area in Midtown with 75 other offices in the building. There's 200 dentists and 4 orthodontists. So being on the ground floor, I'm bound to meet 1 or 2 sales reps, whether they're going into the building or coming out. And JP came into the office and is talking to the front desk. I didn't know it was just a salesperson because I saw my front desk's eyebrows. She's got these gorgeous eyebrows. One went up and one went down. And she said, braces, huh? And she met you at the AAO and she wants to put this into her practice. But we're really easy. If you want our undivided attention and my team's undivided attention, all you have to do is feed us. Well, this sales rep had us at hello because after he left, he also sent us chocolate-covered strawberries. What I didn't realize is that during that lunch and learn, I learned that a 3D printed custom bracket with its own base doesn't have to be placed vertically along the tooth. It is a prescription. It's very similar to the clear aligner treatment that I have. What I also didn't know is that it would open up a whole new world of opportunity that has changed how I think about fixed appliance therapy. You see, the allure of being an orthodontist started to fade recently when I was being lumped into a category of drive-through clear aligner orthodontists and the direct-to-consumer because they're opening up. And now I felt like I can still treatment plan and design and be a part of that patient's treatment. Yesterday at one of the seminars, I heard it called boxed orthodontics. So now I have an aesthetic alternative that's faster with less visits. And guess what? Less compliance. It is a practice differentiator. Absolutely. And it's easier for conversions in my office. We find it a very valuable marketing tool in our practice. I know that patients are intuitively and they understand customization. You know what? It wasn't so much that I didn't enjoy fixed appliance therapy for my patients. I wasn't willing to give up all of the years of advanced technology of clear aligners. And guess what? Now I don't have to. As far as the patient experience goes, well, yes, we breed happy patients. My doors have been closed for 7 weeks. I know my patients' wires are continuing to work while we're not seeing each other, and I'm less worried also of the broken brackets due to their 3D customization. So there's less chair time, absolutely less emergencies, decreased appointment intervals, and decreased overall treatment time, which breeds happier patients and, yes, happier patient referrals. I wanted to truly thank LightForce and the American Association of Orthodontists for being agile, adaptive, innovative to continue to host this annual event, even under the current conditions. I'd like to share with you this presentation. I'd like to dedicate the presentation and share with you this photo about my amazing team. I'd like to dedicate it to one of my assistants who lost her father during this time a couple of weeks ago, and he was really young. He was in his early 60s. This photo is very special. It was taken on our last full orthodontic day on March 12th outside of our office on Park Avenue and 40th in Midtown Manhattan. And that sales rep that I was telling you about is also the director of professional education at LightForce and was there on that day. I want to thank all of you and everyone. Stay safe, be well, and be positive.